Hello and welcome everybody to my talk about a common bypass pattern to exploit modern web apps. So let's just get the introduction out of the way. Who am I? My name is Simon. I am a vulnerability researcher for SonarSource. I work in the same team as Thomas, which I'm very lucky for. I focus on finding, disclosing vulnerabilities with my teammates, mainly in open source software. A couple of examples of software we found vulnerabilities include WordPress, Magento 2, MyBB, Zimbra, and the Linux kernel. Don't worry if you're unfamiliar with some of these targets, and we'll go into more details on the next slides. And I also like to travel, which is why I'm super happy to be here in Geneva. So my goal for this talk is to go into detail about some bug chains we found in popular web applications that have already been hardened and the methodology we use to find them. So first on the list is a WordPress one-click RC via CSRF. The idea was to create a comment on a WordPress blog which shows up in the admin dashboard, because by default an admin has to log in and actually approve comments made by external guests, meaning unauthenticated guests. So, and when the admin views the comment, they're tricked into going on your attacker-controlled website, and then a CSRF vulnerability triggers and executes arbitrary code. And this happened back in the day when same-site cookies weren't enforced, so this actually worked and wasn't just a theoretical issue. So yeah. And then next up, we have found a bug chain in Magento 2. Magento 2 is an e-commerce solution. And we found a pre-auth stored XSS into the admin panel. And the next time an employee logs into the admin panel, RCE exploit was triggered. And we found a similar bug chain in MyBB, which is a popular forum software where an attacker could send an admin a private message or have them view a post. And whenever they viewed this message, XSS triggered again, exploiting RCE. And last but not least, we have a bug in Zimbra, which is an enterprise email solution, where we found yet again an XSS, which triggered in the email body. So whenever a user of a targeted organization will log in and view an email, they wouldn't have to actually click anything. XSS would just trigger and the attacker could steal all their emails. And we found SSRF, which could be triggered by any user of an organization, meaning if anyone just clicked on an email, the SSRF would trigger, steal potentially cloud tokens, and return it to the attacker server. So some of these applications have been hardened through years of bug bounty programs, and there's competition in zero-day market. So some of these bugs are actually, being sought after by SSD and the likes and CDI, and static analyzers have been thrown at them as well. There have also been security audits, but the bugs still occur, and the question is why, and that is what we're going to discuss in the next slides. So I feel like the way we find web security bugs is changing for modern apps. So we've seen a dramatic increase in adoption of mitigations and secure by default framework. So in the past, a PHP app would simply, you'd have a script and then you would echo user input and then you'd escape it on the spot, instead of having a templating engine that would, make sure everything is escaped by default and kind of so there are tons of great sanitization libraries available, and they're quite easy to use, making it appealing for developers to actually use them, because they're just, not a pain to integrate in your project. And in general, I would say security awareness has greatly improved among developers, at least for these huge projects that are modern. So whenever a new mitigation or sanitization framework is deployed, we have to look for bugs in places that are not covered by this new mitigation. So this forces us to improve security research and invent new ways to find vulnerabilities. So this means instead of finding a place where they forgot to escape user input, we would actually have to come up with a way to either break the sanitizer to begin with, or find a place where they wrongly use the sanitizer. So, we get the same bugs, but in a different way. So for example, parser differentials are one of my personal favorite bug classes. The basic idea is that you have two different components of an application. For example, a component that validates untrusted user input and one component that actually uses it. And if they don't agree on how to parse this data, there can be security issues. And OrangeSide did an incredible job at demonstrating this with differences in URL parsers and file system parsers. And those then led to good old path traversal bugs. And HTTP request smuggling is another great example of this. Also, just in general, whenever a standard leaves room for interpretation or there's some unintended side effects, for example, PHP FAR deserializations were a new way a couple years ago to get the same old PHP unserialized bugs that we've been exploiting for years. And another example of more sophisticated ways are maybe race conditions or time of check, time of use bugs. But essentially, we're still finding the same old vulnerability types like XSS and SQL injection and other injections, but we have to get more creative to get to them. So I mentioned a couple, and something we felt wasn't getting enough attention was another common mistake we saw everywhere, which was modification of sanitized data. And this is what we're going into in this talk, and just give some examples on what we mean by this. So the mandatory hacker code picture, and although I'm usually a bit put off by images like this when I see them in articles, I think it represents quite well how intimidating it can feel like to look at the new code base, at least for me. There might be millions of lines of code across several GitHub repositories and different services, and there might be different programming languages involved, and there's a front end and a back end, and you have no idea how everything fits together. So for this reason, we want to build a model so we can concentrate on what is important to us and what isn't, so we can cut through millions of lines of code, because we can't just read the application line by line and expect bugs to fall out. So let's use some pseudocode to describe a model. In this example, we have some user input. This can be anything. This could be your HTTP get or post parameter. This could be a HTTP header that is received. That is a file that was uploaded or generated from user input. Anything where you have untrusted data in. In the example above, we see that this is sanitized. It's just could be anything. This is, on an abstract level here. This could be your HTML escaping. This could be your SQL escaping. This could be checking that a file name works. And then you use the data in some way. So that's generally how it works. However, in the real world, usually things are more complicated. Like you'd have your user input is transformed, it's normalized, it's validated, it's sanitized, it's processed. And it's important to note that these steps, they're not always like at the same code in the next code lines. Like sometimes there are millions of lines of code apart, and sometimes it's not even explicit when something gets normalized, for example, and we'll get into some examples with this later. But just to give you some examples of something we observed commonly happens in web applications with user input for transformation. So you would have something like converting shortcodes to HTML. We typically see this in forums or some kind of what you see is what you get editor, where you have like a backend format for shortcuts, or modifying or adding HTML attributes to an HTML string. So let's say an application takes in HTML input from a user, or a document that was generated from user input. It could be your, if you have an online store, it could be your template for emails that are sent to customers, whatever it is. And you kind of want to make sure that the HTML code is SEO friendly by making it clean, making sure it's accessible. So you want to make sure you add you add attributes just to make sure it's clean HTML code has a good score. Censoring of text. Let's say you have a chat application, you want to make sure your users don't send nasty messages to each other. You can remove swear words, for example. And there's also auto URL highlighting. That's super common in chat applications, mail apps. Whenever you send someone a message and they detect, okay, there's something like www.google.com, then they transform it into like a clickable link just to make sure it's easy to use and useful. And language translations are also a common thing to do. So looking at our code example here, another step in the typical life cycle of user input processing would be normalization. So let's look at some examples what this could mean. So Unicode normalization and text encoding normalization in general. So you want to make sure that all your services, for example, your web app and your database and your caches and whatever, that they all agree on a character set and that they consistently use it. Otherwise, you might run into some issues. Path normalization, say you want to build a real path from user input and kind of resolve the path. That's something that happens. Or converting backslashes to forward slashes. If you have an app, commonly Java, that can run on multiple OSs, kind of to make sure all your paths are normalized and actually work for the OS it's designed for. Length truncations are quite common. For example, some fields of a database might only be able to contain n characters. And if there's user input that is longer than n characters, it will be truncated to the defined length. And last but not least, all your services need to agree on how many times user input should be URL encoded and decoded, just to have kind of a common base, normalized base across your services. So last but not least, let's look at the sanitization step. And could be, well, this is more validation when you have extension checks, when you will let your users upload files and you want to make sure they don't contain any malicious file names or file extensions. This could be with an allow list or a deny list, whatever approach you want to take. HTML escaping is, the backbone, making sure you don't have XSS everywhere, and the same applies for escaping input for your SQL queries. Just make sure your apps don't explode whenever someone enters a single quote. And then you want to validate your input against allow list in general. Say you have a RPC service, remote procedure calls, and you want to let users call methods. You want to make sure they can only call methods that are actually allowed, and not just any random method in the code, which might lead to RCE. So let's get to the fun part and think about how this could break. So looking at this pseudocode, we can see an application accepting user input, and they sanitize it, and the resulting data is then normalized and afterwards transformed again, and then it is used. And this is possibly insecure, because when sanitized data is modified in some way, the effects of the sanitization could be negated, or possibly even worse. So sanitization should always be the very last step before using data, and we'll get into more examples here. However, sanitized data tends to be trusted and used less carefully, because you're a developer and you've done your deed and you threw the sanitizer at it. Now everyone's happy, and now you can do whatever you want with your input. But it isn't exactly how it works in the real world. And also, it isn't always obvious if, how, and where data is modified after it has been sanitized. There are cases where data is modified by some other service before being used in an entirely different GitHub repo maintained by a different team. So you don't have a perfect overview over it. And also, I noticed that a lot of Wone researchers, when they look at code and they see some user input is validated or escaped, they just stop following the user input, and they don't look for a place where it's modified after, and perhaps you can bypass the sanitization step. So let's get into some case studies. And the first one we have here is Zimbra Webmail. And we mentioned this before. It's an enterprise email solution. It can be used as an alternative to Microsoft Exchange, for example. And according to their sales website, there are over 200,000 businesses, government, and financial institutions that are using it. And actually, in February, Volexity published a blog post where they detected a zero-day campaign against Zimbra, and they assumed that it was a state actor because government instances were the main targets of these attacks. So it goes to show it is an interesting target used by governments, and email bodies can contain arbitrary HTML code, and it must be carefully sanitized, and there's a lot that can go wrong here. So we chose it as an interesting target for pawning. So we discovered an XSS vulnerability in the email body and an SSRF vulnerability that allowed stealing cloud provider credentials, for example, from AWS or even Google Cloud. With Google Cloud, you usually need to send a header, but in the SSRF, you could actually send arbitrary headers, meaning you could even steal Google Cloud tokens, which was pretty cool. So one email is enough to potentially take over an email server of an organization. Just someone needs to click it. And we have a little demo prepared here. Let me just switch tabs. Okay, so I wrote my little fancy attacker dashboard here, and let me just skip back. Okay, so what we're looking at here is the attacker dashboard that I wrote. It's just for demonstration purposes, and we basically have an attacker launching an attack against employee@target-organization.org, and when the attacker presses this button, an email is sent to this victim. And now we're switching to the victim's view. They're logging into their Zimbra instance, and now they have a new email. And you can take as much security training in the world and be as careful as you want and not click on any links in any emails, but at some point you're going to have to open emails. So there's a new email, they click it, and there's nothing to click, there's nothing evil going on, there's just an awfully cute puppy. And they view the email, and while they're viewing the email, XSS payload runs in the back. So now we're back in the attacker panel, and when we reload, we'll see that we have leaked all the emails of this client. And well, there's one email with Office Banter as a subject, so that's probably not interesting. And just for dramatic purposes, there's an email with the subject of access to production environment. So that might be interesting. And we have also leaked IAM credentials. And when we read the email of the victim, we now have access to production environment. It's probably not that easy in the real world, but for demonstration purposes, I hope it's fine. Okay. So let's look at how the vulnerabilities actually came to be. So we looked at the sanitization of email bodies in Zimbra, and the email bodies were sanitized on the server side, and they used an allow list of HTML tags and attributes, which is generally speaking the good way to go. Oh, sorry. Thank you for pointing this out. Okay, there we go. Okay, thank you. Server-side sanitization, they use server-side sanitization, and they use an allow list of HTML tags and attributes, which is the way to go in my opinion. Deny list never actually works. And they use the OWASP Java HTML sanitizer. It's a library maintained by OWASP, and we did not discover a bypass in this HTML sanitizer framework. So our thought, and additionally there was very strict encoding, meaning all the ampersands and the angle brackets and the quotes and single quotes, they would all be escaped in text and attribute values. So our thought was, hey, we'll have to start looking for a place where the sanitized email is modified after it has been sanitized, just to find a bypass for this. So we found a code snippet in a JavaScript file located in another repository that does exactly this for us. So it wasn't immediate obvious. So for background, emails can contain calendar invites. So whenever you invite someone for a meeting, that's just a calendar invite basically. And if such an invite was present, the front-end JavaScript file was used to truncate the HTML description of the invite. It's basically just, having a fancy read more button for calendar invites. And so let's look at actual code. If the JavaScript file checked if there was invite content, and if there was, it would enter after checking some other headers, which I don't know anything about. They enter the truncate body content function, and they pass the content variable to it, which contains the string of the sanitized HTML data that is partially attacker controlled, partially because it's been sanitized. So then within that function, they created a wrapping div tag, just creating and then they set the content to the inner HTML of this wrapping div. What this does is it will utilize the browser, and the browser will then parse this HTML string and build a DOM object tree from it. And this allows you to just kind of search within this DOM object tree by ID and class and do all sorts of modifications to it. And it's kind of neat. And after all of this processing, which we're actually not interested in, basically they just added a read more button. They return the inner HTML string. Now something interesting happened here. Because setting the user-controlled and sanitized HTML content to .inner HTML of a wrapping div decodes HTML entities in user-controlled data. So this is because browsers parse the inner HTML string and convert it to a DOM object tree, as I said, and they normalize it kind of in their browser-specific way. There are some standards, but there's deviations and whatever. So when the .inner HTML string is then read, the DOM object tree is converted to HTML. And we now have the normalized version, which now has decoded entity. And this does not lead to XSS directly, but is important for the next step. And we'll show how this would look like with a real user input in just a second. So the same JavaScript file transformed the normalized data further. So it looks for form tags without an action attribute. The reason for this is that emails can contain forms. And if you don't, because they use the server-side sanitization to throw out anything that could potentially be harmful, but they couldn't actually check if an attribute was not set. So if a form tag doesn't contain an action attribute, which dictates where the form should be submitted to, it goes to this current page. And technically, you could forge a CSRF attack So they would try to find all form tags without an action attribute and then set a default one just to kind of prevent these kinds of attacks. So, looking at code, and please don't be scared because I was when I saw the regex here for the first time. Basically, all it does is it uses regex to find any forms within the HTML, which has now been decoded, to find form tags. And if they do, they just insert the attribute action equals, and I can never say this, same host form post blocked action attribute, just kind of killing all these CSRF attacks. So let's actually look at some code, and let's assume the following HTML that was sent in an email to a victim, and we can see an HR tag. It's harmless, so it's left by the sanitizer, and there's an align attribute, and within this align attribute, there's a form tag. And we can maybe see already where this is going, and there's a second attribute, the no shade attribute, and this contains a script alert document .domain. And although it looks nice, there's a script tag, it's actually completely harmless if you were to render this in your browser, because the form and script tag are encapsulated in double quotes, and they're interpreted as an attribute value instead of tags. So after the sanitization step, even the ankle brackets have been escaped, and this is even more harmless. However, now we can force the browser to decode these entities again by setting the .inner HTML string, kind of leading to a bypass of this encoding. And I said before, this does not lead to XSS directly, but it's important for the next step, because now the regex that's looking for form tag can actually match the form tags within the align attribute. And what this means is the action attribute, default action attribute, is inserted within the align attribute. And this kind of leads to an imbalance of double quotes within the HR tag, meaning the script alert is now actually interpreted as an element instead of an attribute string, which then leads to XSS when it's viewed by a victim. So to summarize the Zimra vulnerability, here's what happened when looking at the code through the lens of our model. First, the user input is sanitized on the server side, and then it was normalized by the .inner HTML normalization. And afterwards, the form replacements were kind of transformations on the code. And finally, it was used and was displayed to the user, leading to XSS. Okay, so let's look at the next case study, which is WordPress. And yesterday, when I checked just before updating the slides, the download page of WordPress says that 43% of websites on the internet use it. I mean, I don't know where they have their number from, but it's on the download page. And it has a comment form enabled by default. So any unauthenticated visitor can just create a comment, and this comment can contain raw HTML code. And we finally ended up discovering a chain of vulnerabilities leading to CSRF to RCE impact in default settings. And I mentioned this earlier, at the same site cookies weren't enforced, so this would actually work. So I mentioned the comment form before, and they were not protected by a nonce, and this will get important later. And they can contain raw HTML code, which becomes sanitized. And they have actually a very strict list of tags and attributes that are allowed. So it's extremely limited. You can make your text bold. You can, make the text cursive or underline it, or you can include links, but that's about it. However, for admins, this sanitization list is a bit relaxed. You can include some more tags like images and tables, but it's still secure. At least we didn't find a bypass. So the WordPress HTML sanitizer has been hardened for years, and I think everyone tried to break it before, and I definitely didn't manage it. So we were kind of hoping that maybe there's a place where we can apply our little trick again. And it uses an allow list for HTML tags and attributes, one for admins, one for unauthenticated users. And we did not discover a bypass for the sanitizer. So look for a place where it was modified. And we found a transformation of the comment where A tags, like meaning links, are actually transformed. So for SEO purposes, you want to make sure that a rel attribute is present. This kind of just gives search engine some hints about how to parse the page, and just kind of improves your score so that you are shown on a higher entry on Google results, for example. And only administrators could set this rel attribute. An unauthenticated user can't, which is fine because we can just CSRF the comment form and create a comment containing the rel attribute. And WordPress parsed the A tags, which have already been sanitized, so all evil attributes have been thrown out. And they created kind of a key value array or a map with all the attribute values, and the A tags are then constructed back together after processing the rel attribute. So let's look at some code. And what we can see here is the key value map of attributes in the ads array. And on the first line, it is checked if it's empty or if the rel attribute exists. And if it does, it will process it. And again, this isn't actually relevant to us, what we're trying to do here. And then the attribute value string needs to be constructed back together. So you would have something like title equals double quote some value, blah, blah, blah. And then you have the href equals something. And this needs to be constructed back together. So they iterated over all the attributes that were previously parsed. And then they set the name equals double quote, the value double quote, and concatenate everything back together. Note there's no encoding here. And then they just return the string again. And this is kind of used to sanitize comments, to transform comments. So let's assume the following input. And some people might already know where this is going. We have a tag here with a title, and it's encapsulated using single quotes. And there's a XSS, and there's a double quote. And then there's an on mouse over equals evil code string, and an ID, another double quote, and the final single quote. And again, it would be nice if we could just include the on mouse over event handler on the raw HTML, but we can't because it's kicked out. And however, you know, there might be a way. And then there's also the rel attribute set. Now we saw just in a slide before how everything is concatenated back together using double quotes. So after the concatenation, our input would look like the following, where the rel no follow tag is set after it's been processed. And then suddenly you have the title attribute encapsulated in double quotes. And because nothing was escaped, we can now actually inject the on mouse over event handler. And it's now interpreted as an attribute instead of a string, leading to XSS when an admin would hover over the mouse, use their mouse to hover over the A tag. And we could also inject this style tag and make the link like an invisible overlay over the entire page. So basically it triggers instantly. And to summarize, with this bug, input was again escaped and afterwards transformed and used. And that's all we were doing. Basically, we're just looking for places where things were transformed after it was sanitized. So I prepared a little demo again. Okay, so on the left side, we'll have the attacker launching their little exploit server. And on the right side, we have a WordPress page where an admin will log in. So we're starting an exploit server on port 1337, of course. And then we want to run the command ID on the targeted WordPress server. And then we have the admin logging in. And now they see a new comment has been created, and it says, hey, admin, I thought this blog post was really great, and here's an interesting URL. I left some criticism here. And of course, your ego stinks now, and you want to see what someone had to say about your blog post, so you click on the link. And now the victim is kind of just seeing the Insomnihack logo and just viewing. But on the left side, we can see that a connection was made to the exploit server. And now we're exploiting the cserv to create the comment. Now that the comment was created containing the XSS payload, we can actually display it on the same page in another iframe and make the iframe follow around the victim's mouse, just so that the almost over event handler would trigger. And then we're checking if the XSS worked, and it did. We got a connection, and now we're uploading a shell. So in WordPress, you can just upload a shell as an admin, basically, because you can upload plugins containing PHP code. And then we see the output of the ID command here, and we have our CE. Okay, so let's get to our final case study, and this is a quick one, and then afterwards we'll summarize, and we'll be done. So Magento 2, we said earlier, it's an e-commerce solution that is used by thousands of companies to handle hundreds of billions of dollars in annual transactions. And there's some people here in the audience that are really well versed in Magento. And it's a popular target hacking group motivated by financial gain. For example, MageCard has been observed to utilize 0 days against Magento 2 stores. So it's a popular target. And we looked at a post-auth RCE, and low-privileged employees could create a sitemap XML file. That's just kind of another hint for your search engines on how to parse the site and, just to index some interesting pages. And the file names had to end with the .xml extension. So you could control the file name, but there had to be an XML extension. And the file name and content were stored in the database. And when desired, the sitemap file could then be generated and written to disk. And the file name check was secure, unfortunately for us as attackers. And however, again, we looked at a place where stuff is normalized afterwards. And the database column for the file name was limited to 32 characters. And there was no length check. However, the database driver would truncate the file name to 32 characters if it was too long. So what this means in practice is we can create a file name like the first one, which is 36 characters long, but ends with the .xml extension, and thus checks, it passes the check by Magento. However, after it's been stored to the database, it turns into a .php file, and we can just ask Magento to generate the file, then write it to disk, and then we have RCE because we have uploaded a shell. So that's another example of something being normalized and actually being implicitly normalized, because, the database, MySQL, just does it without, you ever knowing that it was truncated. And the developers technically didn't do anything wrong. It was kind of, just an unknown side effect where normalization took place of validated data, which just goes to show whenever you have data that's sanitized, it's not time to stop looking. There might be a way to bypass. And so we have another demo. So this one, we use kind of a fancy RIP shell. What we're seeing here is the attacker being on a targeted store and using some JavaScript to launch a fancy RIP shell just for dramatic purposes. I used to work for RIPS, which was acquired by SonarSource, just for context. So they now, and I mentioned earlier, we found a pre-auth stored XSS into the admin panel. So in this exploit chain video, the attacker is unauthenticated, and then they register a customer account on the website, and they create an order, cancel the order, and within the order cancellation notice, there was the XSS payload, which actually works because of a similar trick again, but I wanted to keep this short. And now we're waiting for an administrator or any employee to view the canceled order. And in the real world, this could take days or even weeks. But just for dramatic purposes for the video, this will happen instantly, where the administrator views the order. And as soon as they do, the XSS payload triggers and executes the RCE exploit we just demonstrated. And now we have a shell on the Magento store. So yeah. Okay. So just to summarize, abstracting vulnerabilities helps to find bugs in highly complex and large code bases, because we want to have something we want to focus on. And abstraction also helps keeping the big picture in mind when auditing projects. And yeah, just my personal tip is my little go-to trick nowadays. So whenever there's something sanitized, I don't stop looking. I just look for a place where this is somehow modified, the data, and then sanitization for developers should always be the last step, and never do anything with your data after it's been sanitized, except for using it, of course. And then blog posts, you can see that we can read the details about the Magento XSS on our blog. It's blog.sonarsource.com, and we would love your help at SonarSource to find bugs. So if you want to join us and do similar things, we're hiring. And yeah, you can reach out to me on Twitter, ask me any questions, or if you ever find a bug with this pattern or have found bugs with this pattern, it would be really cool to hear and read your write-up. And yeah, thank you very much. Now, if there are any questions.
Hello, thanks for the great talk. So I was wondering, this methodology that you show in this bug class where the unsafe things happen after the sanitization, it seems that it could be found by static analysis, maybe, with all the usual caveats about static analysis. Have you seen or done any attempts of automatization with this regard?
So I think that RIPS detected some instances in the case, or old static analyzer, because you can just kind of check, okay, is my user input here, and what happens with it, and then you can see would this transformation kind of make exploitation possible again. So it's definitely possible. You would just have to, I'm personally not a engineer for static analysis, so I'm just way out of my water here. But in general, yeah, you can detect, you can mark something as sanitized or validated, and then you can keep following the data flow and just check if it's modified in any way, and then just raise a warning or something.
Yeah, because currently it's like a static analysis, like when the data is sanitized, it's after that is considered saved usually, and no sync analysis is done. So I was wondering if you know of any products that that go with your solution. Thanks.
Yeah, thank you for the question.
Is there any other question? No, sir. Then thank you very much for your presentation.